Hello everybody, welcome to section 4.2 basic differentiation rules and rate of change. These video objectives are you are going to learn about the derivative of a function using the following, using the constant rule, the power rule, and the constant multiple rule. They all super easy. You'll enjoy these guys. Big names, but a very easy concepts. The first theorem you're going to study today is called the constant rule. The derivative, guys, this notation is the notation of the derivative d over dx of a constant c is equal to 0. The derivative of any constant is equal to 0. Look at this example. The derivative, we need to find the derivative of each function to the left. The first function y equals 7. What kind of function is that? That's a constant function. So the derivative y prime, we can use lots of notation, several notations for the derivative. One of them is y prime is equal to 0. Second function, f of x is equal to 0. It's a constant also, guys. F prime is equal to 0. What if I have a negative constant? Does the situation change? No, guys, same thing. S prime is equal to 0. Oh, the last one is kind of tricky one. Y equals k pi square. K pi square. Guys, k is a constant and pi is also a constant. So the whole thing is a constant, and the derivative of a constant by the constant rule is equal to 0. So y prime is equal to 0. So in conclusion, the derivative of a constant is equal to 0. Second rule, second theorem, the power rule. If we have a function f of x, okay guys, and we need to get the derivative of this function, and this function is raised to the power n, the derivative of this function is equal to n times x to the power n minus 1. What's that? What's going on? Guys, this is very easy. You bring this n down, you bring this power down to be the coefficient, and you decrease the power n by 1. You decrease the power by 1. So that's going to be n times x to the power n minus 1. Let's see a couple of examples, guys. Examples are easier than theorems. Look at this. We need to find the derivative of each of the following functions. The first function is f of x equals x to the power 3. Guys, n is the power is 3, so don't get distracted because of this. Now I need to find, my job is to find the derivative of this function. F prime of x, the derivative of this function is equal to, what do I do, guys? You bring this power 3 to be the coefficient of the function, times you reduce the original power by 1, so it's going to be x to the power 2, and that's it, 3x squared. This is the derivative of the function. This is the slope of this function. This is the slope of the tangent line of this function at any point. Part B, g of x is equal to the cube root of x, and the power is 1 over 3. Guys, I can rewrite this function in exponential form. Exponential form is easier than radical form. That's equivalent to x to the power 1 over 3. And now we need to get the derivative of this function, g prime. G prime is equal to, we applying the power rule. What is the power rule, guys? You bring this coefficient, you bring this power to be the coefficient of the derivative. That's 1/3 times x to the power, you reduce the original power by 1. Guys, what is 1 over 3 minus 1? 1 over 3 minus 3 over 3. That's negative 2 over 3. Negative 2 over 3. And now you need to simplify your function. You simplify your derivative. You create fraction bar, you keep the 1 on the top, you put this 3 down, and you bring this negative exponent down in order to be a positive exponent. So it's 1 over 3x to the power 2/3. Do I need to put it in the radical form? Not necessary. You can just leave it like this. But if you want to put it in the radical form, it's okay. That's going to be 1 over 3, create radical. This 3 goes outside to be the index of the radical, and inside or underneath the radical we have x squared. Both forms are accepted. Another function, y equals 1 over x squared. My job is to find the derivative of this function. I need to find y prime, the derivative of this function. Do you remember the rule, guys? Yeah, but this function is written in a fractional form. So we can rewrite the original function before we start. The original function can be written x to the power -2. You bring it up. You try to eliminate the fraction. Okay, guys, as the previous one. In the previous one, we tried to eliminate the radical. Now we can apply the power rule. We can bring this -2 to be the coefficient of this derivative, and we reduce the x power by 1. That's going to be x to the power -3. Now let me simplify this, guys. Create a fraction bar, keep the -2 on the top, and bring this negative exponent down to be positive. Negative exponents are not allowed, are not accepted. We simplify our derivative and we put it in the simplest form to be -2 over x cubed. So far, so good, guys. Yeah, two rules so far. Another idea covered by example number 3, finding the slope of a graph. How do I find the slope of a graph given by this equation? Guys, this is our graph. This is our curve. F of x is equal to x to the power 4. And what do I need? I need to find the slope of this graph when x equals some different values, when x equals -1, when x equals 0, when x equals 1. So how do I get the tangent line? How do I get the tangent line? By finding the derivative of the function. This is what you learn in section 4.1. So first of all, guys, I need to get the derivative of the function f prime of x. F prime of x is equal to, apply the power rule, guys, bring this 4 down to be the coefficient of the expression and reduce the power of x by 1. That's going to be 4x to the power 3. This is what? This is the derivative. Okay, guys, this is the tangent line of this, curve. But we don't need the equation of the tangent line. We need the slope of the tangent line. How do I get the slope? By substitution, guys. Now, at x equals -1, the slope is m equals f prime of -1. Insert -1 in this equation, the equation of the derivative. That's going to be 4 times -1 to the power 3 is equal to -1 to the power 3 simplifies -1. -1 times 4, that's -4. So the slope of the tangent line of this curve at x equals -1 is equal to -4. Now let's repeat the same thing when x equals 0. When x equals 0, the slope of this tangent line, m equals f prime of 0. F prime of 0, 4 times 0 to the power 3. The whole thing simplifies 0. And finally, I need to find the slope of the graph at x equals 1. At x equals 1, the slope of the graph m is equal to f prime of 1. F prime of 1 is equal to 4 times 1 to the power 3. 1 to the power 3 simplifies 1. 1 times 4 simplifies 4. Pretty cool. In example number 4, we need to find the equation of the tangent line. Guys, please think about the difference between example 3 and example number 4. In example number 3, we needed to find the slope. Okay, guys? But in example number 4, we need to find the equation of the tangent line. Guys, how do I write an equation of a line? You need to use the point-slope form. Do you know the point-slope form you studied in grade 9? In order to use the point-slope form, you need a couple of things. What do you need? You need 1 point on the line, 1 point on that line, or on that curve, and you need also the slope of the line. How can derivative help us, guys? We can get the derivative of this function and we can conclude the slope of the line, of the tangent line, okay, guys? And if we can have 1 point, we can apply the point slope formula. The example says, Find an equation of the tangent. Guys, determine your target from the beginning. Your target is to write an equation of a tangent line of the graph f of x equals x squared when x equals -2. First of all, guys, we can evaluate the original function at x equals -2 in order to get the point. Remember, finally, we are going to use what? We are going to use the slope, the point slope form. So we will need a point. In order to get this point, we need to evaluate the original function at x equals 2. So evaluate, step number one, evaluate f of -2. F of -2 is equal to -2 to the power 2 is equal to 4. So guys, now I am sure 100% the point -2 and 4 is a point on the graph. So when x equals -2, the corresponding y is 4, and this ordered pair is a point on the graph. That's point on the graph of the function. That's good. So what do I need, guys? I need the slope of the tangent line. How do I find the slope of the tangent line? Step number 2, by finding the derivative. So step number 2, let's find f prime of x, which is equal to the power rule, guys. We bring this to, okay, we're trying to differentiate x squared. So you bring this a power to be the coefficient of the derivative, and you reduce the power of x. When you reduce power 2 by 1, it becomes 1. So x to the power 1, but nobody writes 1 on the top. So this is the derivative. I need to evaluate this derivative at x equals -2 because I need what? I need the slope. So the slope m is equal to the derivative of -2. Derivative of -2, if you insert -2 in this equation, the equation of the derivative, you get 2 times -2 is equal to -4. Guys, we almost done. We have a point and we have the slope of the tangent line. So remember our mission from the beginning? We need to write the equation of the tangent line. So step number 3, let me use the point slope formula. Y minus y1 equals the slope times x minus x1. I have all necessary information to write the equation of the tangent line. Y minus y1, the y coordinate of the point is right there. It's 4. Y minus 4 is equal to the slope -4 times x minus the x coordinate, it's -2. X minus -2 turns to be x plus 2. I can simplify this equation, distributive property, -4x minus 8, and I can isolate the y by adding +4 to both sides. If I add +4 to both sides, I will get y isolated and is equal to -4x minus 8 plus 4 simplifies -4. Here we are. This is, guys, the equation of the tangent line of this graph by the help of the derivative. One more rule in this video, guys, the constant multiple rule. Constant multiple rule. Whenever you have a function f multiplied by a constant, so if you have a function f and this function is multiplied by a constant c, if you want to get the derivative of this function, simply get the constant outside. Get the constant outside. So the derivative of this function, when the function is multiplied by a constant c, simply is equal to c times the derivative of the function. You factor out the constant. Yeah, guys, it does make sense. So let's apply this idea. Using the constant multiple rule to find the derivative of each of the following functions. The first function, y equals 2 over x. What is my job? I need to find the derivative of this function. Okay, guys, let me rewrite this fractional function into the regular way, into a try to eliminate this fraction. So that's going to be 2x to the power -1. So that's my job. I need to find the derivative of this function. Now, guys, let's apply the constant multiple rule. You just studied the constant multiple rule. Whenever you have a variable or a function multiplied by a constant, you can get this constant outside. So this is 2 times the derivative of x to the power negative 1. Now, guys, let me copy this 2 and get the derivative of x to the power negative 1. Do you remember the power rule? Yeah, you bring this negative 1 down and you reduce the power of x by 1. It was negative 1. Now, when you reduce it by 1, it's going to be negative 2. Now, let me simplify my answer, and put it in the simplest form. 2 times negative 1, that's negative 2 x to the power negative 2. Negative exponents are not in the simplest form in mathematics. So let me keep the negative 2 up and bring this x to the negative 2 down in order to be x to the power 2. Part B. We given a function, but the variable this time is not x. F of t equals 4t squared over 5. I need to get the derivative of this function. So my job is to get the derivative d of t. Remember, guys, we're not using x this time, of the following function: 4 over 5 t squared. By the constant multiple rule, I can take the constant 4 over 5 outside this derivative and get the derivative of the variable t squared. 4 over 5 remains the same, and the derivative of t to the power 2, you bring this power down and you take 1 from the power of t squared. It's going to be t to the power 1. That's it. And now simplify your answer. 4 over 5 times 2, that's 8 over 5t. The derivative is already in the simplest form. One last part. Y equals 1 over the cube root of x squared. Looks annoying? Yeah. You know why? Because this function is given in the radical form. Let's turn this radical form into the exponential form. So what is my job? My job is to find the derivative d of dx of the following function. And I'm going to turn my function into the exponential form. In the exponential form, guys, this is going to be 1 over x to the power what? That's what we call a rational exponent. The index of the radical 3 goes down and the power of x2 goes up. So this is equivalent to 1 over x to the power 2/3. Still in annoying form because it's in the fractional form. Can I get it up? Yes, this is equivalent to the derivative of the following: x to the power negative 2 over 3. Yes, guys, when you get something from down to up, you change the exponent and you make it negative exponent. Now let's apply the power rule and get the derivative of this exponential function. Is equal to, get the exponent down to be a coefficient of this derivative, negative 2 over 3, and reduce the power of x by 1. When you reduce negative 2 over 3 by 1, negative 2 over 3 minus 1 simplifies negative 5 over 3. So the new power is going to be negative 5 over 3. Now we need to simplify this. We need to put it in the simplest form and get this negative exponent down. So I'm going to leave a negative. I'm going to leave negative 5 on the top and put 3 times x to the power 5 over 3. That's going to be the simplest form. In the last part of this example, I need to get the derivative of the function y equals 1 over the cube root of x squared, radical function. So my job is to find the derivative d over dx of the following, and I'm going to turn this radical function into exponential function. 1 over, if you want to turn this function from radical form to exponential form, you create a rational exponent of x, and you get this outside number, we call it the index, you get it down, and you get the power of x to be the numerator of this fraction. So that's the derivative of 1 over x to the power 2/3. Still annoying. This is equivalent to the derivative of the following. I want to get it up. In order to get this exponent from the bottom to the top, you change the signal of the power, so you make it x to the power -2 over 3. Now I can get the derivative of this function. Remember, guys, if you want to get the derivative of any function, you take this exponent, you take this power -2 over 3 to be the coefficient in front of the derivative, times x to the power less 1. -2 over 3 less 1, that's -2 over 3 minus 3 over 3. That's going to be -5 over 3. I get the derivative of the function, but actually it is not in the simplest form. I need to get this negative exponent down in order to be in the simplest form. So I'm going to keep the -2 up and put the 3 down, and the x to the power -5 over 3 on the top will be x to the power +5 over 3 at the bottom. Some more ideas are left in this section, guys. I will see you in the second video. Thank you. Some more ideas are left in this section, guys. I will see you in the second part of this video. Thank you very much.